Everyone, my name is Vijay Sindhumaram, and in this video, I'm going to demonstrate my project on the closest pair of points problem. In this project, I implemented and compared two algorithms, the brute force approach and the divide and conquer approach, to find the pair of points with the smallest distance in a set of randomly generated points. Now, let's start how this program works. This is my actual project, and here I have reduced the size max n to the 500, and which means that largest dataset has 500 distinct points. I also used 10 prefix sizes from 50 to 500 points and ran each test 10 times to calculate the average running time for both algorithms. This code uses a distinct points generating distinct points function which randomly generates unique x and y coordinates for each point. Every point also has an index so that the both algorithms brute force and the divide and conquer are tested on exactly the same input size set, ensuring consistency in the comparison. Here is the brute force algorithm. Checks all possible pairs of points using a double loop to find the minimum distance. This is simple but has a quadratic time complexity, big O of n square, which means it becomes slow as n increases. And down here is the divide and conquer algorithm, which sorts the points by their x coordinates, divides them into two halves, and recursively find the closest pair in each half, and then checks near the dividing line. This point runs method runs much faster than big O of n, much faster with like big O of n log n time complexity. Now I'll explain the running. How now I'm going to run this code here again. So for n is equal to 50, the algorithm takes less than millisecond. As n increases to the 500 in the last iteration, it just takes nearly 76 milliseconds in the first one for the brute force and 4.33 milliseconds for the second one. For each input size, the program runs both algorithms 10 times and stores the total running time. After all runs, it divides the total time by 10 by compute the average running time. Here, as it shows, the printout you see here is the outputs for each iterations. At the end, the average and the constant C1, C2, here C1 and here C2 are displayed, show how the measured time fits the theoretical models. In conclusion, both algorithms produce correct values on the same input, but the divide and conquer method clearly outperforms brute force in execution time. This experiment shows how better algorithm design dramatically improves the performance. Thank you for watching my demo.